Hello all. So in the last session we have discussed about how do we implement simple linear regression using a sample data set. So today in this session I would like to cover how do we implement multiple linear regression using sample data set. So when we talk about simple linear regression, we have seen that simple linear regression is used when you have only one input feature in the given data set, right? So we go for multiple linear regression where we model the relationship between independent variables and dependent variable. When I say independent variables, it's not just one, but we have multiple input features. The main goal here is to predict the value of the dependent variable, that is y, based on these several input features. So the expression for the multilinear regression is given by y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 and so on till beta n xn, where y is the output variable, or we call it as dependent variable, x1 x2 x3 etc. are the independent variables. So depending on how many features we have, we choose that many x1, x2, x3, and then beta naught is the intercept, beta 1 to beta n are nothing but the coefficients for the independent variables that we are taking, that is the input features. And finally we have epsilon, which is the error term, which actually gives you the difference between the actual value and the predicted value. Okay. Now the data set that we are taking here is predicting house prices with multiple features. Okay. So in the previous case when we were talking about simple linear regression, we have seen how does the performance of sales affect based on the amount of advertisement spent, right? So today for multiple linear regression we will try to predict the house prices based on multiple features. Here I am taking three features in the data set. One is x1, which is the size of the house, second one x2, which is number of bedrooms, third one x3, which is age of the house. So depending upon the size of the house, age of the house, number of bedrooms, I want to predict the price of that particular house. So here I have three input features x1, x2 and x3. Based on these values of these input features, I will predict y. So for this cases where you have more number of input features, we go for multiple linear regression. Why regression here again? Because my output is a price variable which has continuous values. Okay. So these are the factors which influence the price of the house, for which we use multiple linear regression. Okay. So this is a sample data set that we have created. The size of the house in square feet, bedrooms, the number of bedrooms, and then age in years. Based on these three features, I want to predict the price of the house in dollars. Okay. So let's start working on how do we implement this. As seen in the last session, the first step would be importing necessary libraries. So here we are importing NumPy, NumPy, Matplotlib and sklearn. So we don't have separate function for simple and multiple linear regression. We have only one function, the same function that we have used in the last session for simple linear regression. We use linear regression function, but here the number of features, that is the input features, would be more. There it would be only one. Okay. So we import NumPy for numerical operations, we import Matplotlib for some visualization, and then from sklearn.linear_model we have imported linear regression. Okay. So NumPy for creating arrays, Matplotlib for plotting, and then the linear regression is the machine learning model, and it is used both for simple and multiple regression. Okay. Now step 2, I want to define the data set. Okay. So here I want to define x and y. When we look into x, I have three different features x1, x2, x3, that is the size, bedroom and age. So that is the reason if I want to create this, I'll create a simple array. Okay, I say np.array list of values 750, 2 and 10. This represents the square feet, size of the house in square feet. This is nothing but the number of bedrooms, and this is nothing but the age of the house. Okay. So depending upon that, I am taking the dependent variable values by creating an array. So I have 5 rows. For 5 rows, I have 5 different values in the output. This is the existing data. Okay. So for this particular existing data, I will try to create a multilinear regression model. As I told you, we don't have separate function for simple or multiple, we use the same function. So here I say model linear regression, and then I fit the data into x and y. So I have already declared what is x and what is y here. So I want to fit that x and y into this particular linear regression model. Okay. So when you talk about the regression equation here, we have size coefficient into size of the house, coefficient 2 into number of bedrooms plus coefficient 3 into age plus the intercept, that is beta naught, beta 1 into the size x1, beta 2 into x2, beta 3 into x3 plus beta naught. Okay, so this would be the expression. Once I create, I'll start predicting. Okay, so dot fit is the function that I use for fitting the input data into the linear regression model. After I do that, I use dot predict. Okay, so y predictions. So y predictions are nothing but for the same y values, what are the values that the machine has predicted. Okay, so model dot predict, I've already created the model here. Model is equal to linear regression, and into this I want to, for the given x values, I want the machine to predict the values. Those y values are the given y values. Now I want for the same x values, the machine should produce the predictions. Okay. Now once I am done with this, I'll try to give new data for prediction. As I told you in the last session, x and y. Okay. So for this x, what is existing y? What is y prediction for the same x? This is one thing. Second thing, change different values of x and then try to predict the value of y. Okay. So here I am taking new data. So I give new house underscore data np dot array. I am taking different house sizes here, and for this particular house sizes, I want to predict the value of y. Okay. So predicted prices is equal to model dot predict of the new house data. Okay, new house data is nothing but the new values that I am taking. Now I want to predict the prices for new x values. Okay, now once I am done with that, I want to display the prices. Okay, so I will just display the prices and then go for plotting. Okay, now when you see plotting for existing data, okay, for plotting existing data I use scatter and plot. For new data again I use green color like how I used in the last session. Now I want to include new predictions, I want to include the predictions for the existing x values and then plot the graph. Okay, now as you can see in the graph here, the blue dots represent the actual data. This line is nothing but y predictions. Okay, red dot, line dot is nothing but predictions, and these green cross marks are nothing but for new x values, what are the predicted values. Okay, as you can see here, I am taking green marker x for new house data plotting, and then I am printing my line graph for the predictions and scatter plot for the actual data. Okay, so as you can see, blue dots for the actual data, red line for the predictions, and these cross marks are for new x values predicted y. Okay, so this is how we implement multiple linear regression. The only difference between simple and multiple linear regression is the way we define x and y. Y would be same, but x will have number of multiple input features. The function linear regression would remain the same. Okay, so in step 1, import the libraries. Step 2, read the data set. Step 3, fit the model. Step 4, predict new y values for the same x. And in step 4, give new x data. And in step 5, for the x new data, predict y values, and then finally do some plotting. Okay, so this is all about how do we implement multiple linear regression using a sample data set. Thank you.